let's give this one a go. Let's give this one a try, shall we? Now, this time, because it was my bent, I went to the graphing method first, and then I went to the quadrant method second. Just different names for the same thing. Just for the sake of it, let's go to this method first and see if we can answer it this way. Okay, so you've got tan, you've got a given domain. Tan is negative, so which quadrants am I interested in?
Second or 4.
2 and 4. 2 and 4. Got it. Okay, so those are the ones I'm going to go to, alright? Now, in my other color, you don't have to worry about the sign when you're working this part out. What's the base angle, the related angle, for tan x equals -1?
45.
So, a way you can think about it, an easy way to get the related angle, and sometimes you have to do this because it's not an exact thing, is you just look at this thing, don't worry about the sign for a second, and you think about what's the first angle that solves that, and it's 45 degrees. Okay, your calculator will tell you that if you do tan inverse of -1. Then you pop the sign back on, and that tells you which quadrants your 45 degrees will be in. Let's draw it. 45 degrees will go that way, so your first angle is, what's the size? 135, right? Because it's 45 degrees that way. Okay, so here's solution number 1. And solution number 2, you told me quadrant 4, right? So I've got to go all the way around this way. So I get 45 here, right? So what's that size? 315. Very good. Okay, here you go. That's it. Nothing too dramatic. Okay, a third example. This time I'm going to switch it up a little bit. Let's go here. Whoops, that's wrong. Okay. So I've changed the domain here, and I'm pointing it out to you. You won't always get it pointed out to you. You have to look for yourself, okay? Now, I will say, like we went straight to the quadrants here. I'll just quickly draw what's happening for this second one, right? This was tan. What does tan look like from 0 to 360? You're going to go up here, asymptote, down, asymptote, and you've got your 2 copies of tan, because tan is periodic every 180 degrees, right? Where are our 2 solutions? -1's going to be somewhere down here, isn't it? So there's your 135 and there's your 315. All happy times, okay? Now, I've been kind of agnostic with these ones as to which approach you use. They're roughly equivalent, okay? But here I think is where the graphical method really starts to take over, okay? Because I could look at this in terms of quadrants, right? Except, if I think about this domain here, right? We usually think of this as 0 to 90, 90 to 180, 180 to 270, and 270 to 360. And that's fairly natural, and you should think about it that way. But that way won't work when you're looking at this domain, will it? Right? Instead, you've got to think, okay, this is going to be 0 to 90, like before. This is 90 to 180, like before. But this is not 180 to 270, because 180 to 270 is not in your domain, okay? And neither is 270 to 360. Instead, how would you suggest I write this? How do I do this? This is going to be negative 90 to 0, and this is negative 180 to negative 90. Okay, now, you don't need me to tell you, this is going to start getting confusing very fast. Okay, it'll still work. You can still get the same solutions. It behaves in exactly the same way. But I find when I teach students this way, they get their signs so confused, it's just not worth it. Okay, so I'm going to ditch the quadrants approach for this, and I'm going to draw a graph. The graph of sine x from -180 to 180 is just as easy to draw as the graph from 0 to 360. There you go. Can you see that's from -180 to 180? We're familiar with this shape, it's just we're looking at a different part. -180. Okay, now this makes it even easier to see where is -1 on this graph. Sorry, where's -1/2 on this graph, I should say. There's -1, right? So -1/2 would be there. Okay, so now I can slice through and I can straight away see where my solutions will be. Bam, 1, 2, and they're both negative. Okay. In fact, because I've chosen such an easy exact value, you can probably tell me what the answers are right now. Right? I'm going to go minus 30 that way. Or I'm going to have to go all the way over to here, which is minus 150, right? Done. No concern about which quadrants you're in. You just look at the graph and you see where it intersects.